Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Remove subfolders from the file system, Leetcode 1233. In this problem, we are given the list of folders called folder, and we should return the folders after removing all the subfolders in those folders. And we can return the answer in any order. If a folder I is located within a folder J, it is called subfolder of it. A subfolder of folder J must start with folder J followed by a slash. For example, /A/B is subfolder of /A, but /B is not the subfolder of /A/B/C. The format of a path is one or more concatenated strings of the form slash followed by one or more lowercase English letters. For example, /Leetcode and /Leetcode/problems are valid paths, while an empty string and / are not. So we are given bunch of folders and we are never given root folder or an empty string. We are always given the subfolders within the root or other subfolders like /A/A/B. So none of these strings will be just the slash folder and none of them will have slash at the end of the string. So we will never get a folder like /A/. It will always be /A. And among these folders that are given to us, we must filter out the folders that are subfolders of other. For example, in the given folder list, we output /A because it's the parent folder. Then we can see that /A/B is its child, so we filter it out. Then we see /C/D and we add it to our answer list. Then we see /C/D/E and it is child of /C/D, so we will filter it out. And finally we see /C/F and we add it to our answer list. So these three folders are included in our answer. Now in terms of solution, one of the naive approach can be to compare each folder pair and check if one folder is parent of another folder. And we can do that by checking if one folder starts with another folder path, that is, it is prefix of other path. And we can use starts with method in different programming languages to do so. But this approach is very expensive with time complexity of O of n square into L, where n is the number of folders and L is the length of the paths. Because first we iterate through each of the n folders and then for each folder we compare it with every other folder, resulting in nested loop of O of n square. And then for each folder pair we check if one folder string starts with another folder string or not, and that takes O of L time, where L is the average length of the paths. So because of this, the time complexity here is O of n square L. But now the question is, can we do better? And the answer is yes. In the brute force, we are comparing all the subfolders or strings. But do we really need to do that? And the answer is no, because folders are hierarchical in nature. That is, parent paths will be shorter than children path and will have same matching prefix. For example, for the given folders, A is the parent and it is parent of folder B. Similarly, C is parent of D and D is parent of E and C is also parent of F. So we can see that parent paths will be shorter than the children path and will have the same matching prefix. So we can use this property when tracing the paths. We should try to trace the shorter parent paths in the longer children paths, and then we don't have to do pairwise comparisons. And how can we achieve that? If we sort the folder paths, we ensure that parent folder will always appear before its children or subfolders. For example, here the list is already sorted, but if it was not, we could sort it and then we can see that parent folder appears before child folder. Similarly, here also parent folder appears before the child folder, as it is shorter and have the same prefix. And now we traverse to the sorted list and check if subfolder's parent doesn't exist, that is, it is already a parent. So we add it to the answer list. But if parent exists, we skip adding it to result or answer list. And how do we check whether we have already seen the parent or not? And the answer is we don't even need the data structure like hash set, because we can do in-place filtering of given folders. As the folders are now sorted, child will follow the parent and parent is at the last index of the answer list. So we can maintain a single index to track valid folders as we iterate through the sorted list. This approach minimizes the space usage while modifying the original list, because we can use a result list as our data structure to find the parent folders. And finally, how can we do the tracing? We have already covered it. We can use starts with method in Java to find the prefix of another string. Now let's see this in action. Let's define our result list to store all the answers. First folder we see is /a, and we can see that the result list is empty. So that means this folder does not have any parent. So we will add it to the result list. Then we go to the next folder, which is /a/b. And we know that now the list is not empty. So that means the last index in the list can be a potential parent of this folder. And here A is actually the parent of A/b. And how do we check it? We can check, does it starts with /a? And the answer is yes. So we skip adding it to the list. Now we go to /c/d and we check, is /a the parent of it? And the answer is no, because it does not have any matching prefix with /a. So we will add it to the result list. Now we come to /c/d/e and check if it is a child of the last parent added to the result list. And in this case it is, because of this common prefix, so we skip adding it to the list. And finally we see /c/f, and it does not have any common prefix with last parent added, that is /c/d. So we will add it to the answer list. And finally our answer has these three elements. Now in terms of time complexity, first we are sorting the array. So because of this, the time complexity becomes O of n log n, plus then we are just going through this folder string in a one pass and then trying to match the prefix using starts with method. So because of this, the time complexity here is n into l. So this will be overall time complexity reducing from n square l to n log n plus nl. And in terms of space complexity, we are storing this list. So because of this, the space complexity is O of n into L, where n is the number of words and L is the average length of each word. Because in the worst case, all the folders can be parent and they all have to be stored in the answer list. So that's it. Now let's jump into the code part. First, let's sort this list of folders. We can use arrays.sort in Java to do that. Let's create result list to store all the parent folders. Since we need to access the last element to check for the potential parent folders, it is more efficient to use an array list. Accessing the element by index in an array list has a time complexity of O of 1. And now our solution is just reduced to one pass. Now we will go through a list of sorted folders. If result is empty, that means we have not seen any folder yet, and anyways the first folder will be the parent. Or if the current folder and the folder at the last index in the result does not have a matching prefix, then we add current folder also to the list of parents. To ensure that we correctly match the prefix of a folder, it is important to append / to the parent folder path before using it with the starts with check. This prevents incorrect matches with the similar named folders. For example, while checking if /ab is subfolder of /a, then if we check without /, it may look like that /a is parent of /ab, which is not correct. So while checking for the prefix, we should add a / to the parent folder. And once we are done with this loop, we can return result as our answer. Let's run this code. Cool, let's submit this code. Awesome. And now the question is, can we do better? And the answer is yes. If you would have already noticed, I have used the prefix term so many times. And which data structure can help us here? That is prefix tree or try. And with that, we can actually reduce the time complexity to O of n into l. But I have not covered the try yet on the channel. So I will try to post that method as a follow-up. Also, for some reason, that code runs little slower on Leetcode. But that is for later. So that's it. I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. Thanks for watching. See you next time.